you so much for introducing me. And it's a pleasure to be invited as a speaker. And thank you again. I'm grateful and honored to participate as a speaker and share some of my thoughts and what are the journeys that we are having in terms of privacy and how do we scale those privacy in distributed ML systems. First of all, after thanking everyone, I also thank the participants who have come here to join. And let me, after my introduction is already given, and I'd just like to start with why we chose privacy. So things are coming around that ethics has become very important subject in the field of ML. And if we are not following the ethics, governance, and one of the most major areas is privacy, if we are losing the sensitivity of the information, we are going to have a deep, very bad time in terms of penalties. And though this penalty may seem very nominal for big organizations, but for startups and running organizations that are getting scale, it's a very important issue. And even we are big, we should abide by that, and we should respect individuals, right? And that is why the thing comes here, the privacy subject has been chosen. And the most important thing is everybody can build models with privacy if you know some of the key aspects, but how do we scale those? How do we measure those? So some of the areas that I would like to cover. So can you, everybody first type whatever it comes to your mind when you, what is the first thought that you think of when you talk about privacy? Anybody in the chat window? What do you think when you talk about the word privacy, ML, all these things are coming? Nothing is coming to your mind. Okay. Proxies and walls, yeah. In distributed systems, proxies do play a big role. Other than that, as anybody else? What is the thought of privacy when you're building systems or when you're talking of ML? Nothing else. So privacy as a human right, as Satya Nadella says rightly, as a human right is going to be recognized, and there will be other regulations. The value exchange around data, it's privacy, or if it is being used, who is benefiting, and all the other things where they are going to be rules that are going to be legislated. The same thing with facial recognition. A lot of jargons. But what he means is that it is a basic human right that we should respect. We should not forget that we are building systems, we are deploying our recommendation systems or whatever solution it is. We are helping users, we are generating revenue. But we should not forget that at the end of the day, we are serving customers and whose data we are accessing, and we should give them a solution that respects basic human rights. Okay, having said that, so what we are going to cover today is the data privacy threats, privacy in machine learning, challenges that are existing in solutions have, and what are the solutions. I do have a demo, but I don't know how much I will be able to cover, but if you are really interested, we can connect later. So what are the data privacy threats? We see that we think that even big organizations are data safe, but they're not. Facebook had ended up giving $5 billion fine, Equifax, British Airways, Uber. Nobody has been an exception. Time and again, we have seen their systems getting compromised, either getting hacked, or they have not maintained the enough privacy rules that respects and governs user-sensitive information. At the end of the day, what happens is that some law or regulation will be able to catch us, or we will be violating those, and we have to pay fines. So none of them, as you see, are exceptions, and how it has happened, if you try to look at, is it right? So different kinds of attacks come into picture, where attacker may have information of the model or may not have. It could be white box or black box. And when we have white box or black box attacks, the attacker just uses some information. Just think it's same. He uses the information, somehow he gets the features, what we are using in the model, and he tries to get the actual record, the actual credit card information, actual age, actual address of the actual sensitive data of the people who with whom we are building the models, be it recommendation systems being used in retail, I'm recommending, be it in Amazon, or be it in some other platform, be it in Walmart's. So either the attacker has information of the model or he may not have information of the model, but he is going to get it somehow. So that's how this white box or black box attacks comes into play. And once he has access, then it's gone. The entire thing is in the hand of the attacker. And that has occurred in the past. See, if you see the NYC Taxi and Limousine Commission, what they have done, they have tracked celebrity information, where they are going, the celebrities, and they mapped that they got the GPS information, they got some of the information that are available for that who is moving, and they map with the correct celebrities, mapping one-to-one from some other sources. That is called linkage attacks. And with that, they got the entire history, right? Where, who is going at what time. As a customer, I won't be interested in leaking those information. I'd want the sensitivity or confidentiality of my location or whereabouts to be maintained. I think, hope you also want those. And it has been same with the military tracker, the Strava's fitness tracker. The military information here you see that which happened in Afghanistan. So attackers were able to trace where the military camps are situated. Even Netflix could not help to protect their systems. Some of the ratings that the user have put it was available on public databases was combined with IMDb ratings and some information from here and some Netflix and some information from IMDb. The attackers used linkage attacks, and they got hold of the entire information of the victims. And the same you would find here in the insurance company. That is the group insurance company. This is a very old attack. We're combining the medical data, some of the information of where the user lives, and the voter information. So the attacker has all kinds of information and he can do whatever he wants to. And these attacks can be alone, like attacker can alone attack a machine learning model, or he can execute federated attacks. What it is? So say a couple of people are using machine learning models, sending data to a server, like how federated learning works. Different devices are sending data to a server, and the attacker comes in the middle. He poses that he is also one of the participants in federated learning. And as a whole, what happens? The server learns the data of the attacker, thinking him that he is also a participant. And now the attacker has controlled the model, the central model, and he has infused wrong information, or he have changed the model behavior. That's how attacks works. This is a kind of a federated attack, what is happening. So instead of, if you are coming from machine learning background, instead of gradient descent, he will change the gradient in such a way it is going opposite. It is gradient ascent. And the attackers can attack, as we have talked about, without having model information, that is the black box attack, knowing where the model is deployed. Say if you're putting the model in a cloud, he will try to use the APIs in a manner that he is not paying the bills, and we end up, who have deployed the models, end up paying the bill. So he does have target. He somehow gets to know that this is an insurance model or this is a recommendation model. And then once he have this information, he has some idea like what kind of features we have. Say he tries to execute attacks, and whether it is a black box, white box, or it is an API attack, by which he gets controls, he gets the predicted outcomes from the model without paying a single charge of the API bill. And this is all possible with all the existing models that if you're thinking of machine learning, whether you are thinking of SVM or HMM, all these models or neural networks or recommendation systems, as we are talking about, we have those attacks possible. Now, my question to you, anybody who has experienced such kind of attacks or are looking into such kind of attacks and looking for, like, how do we scale those problems? How do we protect the systems, machine learning systems specifically, not only big data? Anybody in the looking into their organizations, working in the organizations which they are looking, or they are concentrating in the ethics side of it? Anybody? You can raise your hand. We can take the questions later, but I just want to know what's the feeling that anybody is looking into the ethics side of machine learning. So if not, let's look into, if you're not looking at, then what could be the problem? So there has been laws passed across the globe, be it Canada, California, wherever you are, US federal data privacy, EU, even the communication among different countries have been regulated, and we cannot choose to do what we want. Because at the end of the day, if you are violating system integrity or confidentiality or authentication or authorization or non-repudiation or availability, all these availability, you may think of scaling a systems should be available. But if you are going to violate the integrity, confidentiality, authenticity, or authorization of a user or a customer who is my customer, we are using their information, training models, deploying them. If you are going to violate, and these are the laws which can sue us. Yes, there are regulations, there are petitions, there are federal laws which have been coming, and that's going to be getting more regulated. And it's much more fearful for us that if you're not going by those, we are not sensitive enough for our customers, we are going to end up paying fines and fines. And even if we can't pay fine, we'll see what can happen to us. And health insurance data, these are the HIPAA Act. So many acts, even GDPR, EU and US, they have maintained they have signed a Swiss US privacy shield framework, how data should communicate in between continents. Of course, India also have it. No, now we are not going to pay fines. If you're a startup, maybe it's too much. I can't pay the fine. So violations, what will happen? We'll end up in prison. So it's high time that we concentrate on privacy. What do you do? In which stage are you? Are we at just conceiving the idea of privacy, or we are thinking of how we can embed privacy in models? And also from the models, we take it and put it into a systems which can scale. So our privacy should not get compromised if we have 1 million users accessing the same model. Yes. So before I have to sell my company or have to pay fine or end up in a jail, let's maintain privacy at every end of it. Data governance, data modeling, big data. This is a typical pipeline. Let's talk about. So first, when we get the data from n number of sources, try to get it in an encrypted manner. Try to anonymize the data while we are collecting the information. Then we are collecting from numerous sources. How do we aggregate? At the aggregation level, we also embed noise. Keep it simple. Don't go by the fancy terms. Add some noise, random noise. Add some codes that nobody can make out. What is my data? What is in the sensitive information? Aggregated data, do prediction. At the prediction level, we are getting what we have trained. So the training data already has noise. And then we predict and then we correct. So sometimes we may end up predicting wrong because we have added noise. So how do we maintain that balance? That because I have predicted, something has gone wrong. And why? Because I have added noise. There is not the original data. Feedback, put a feedback that because I have added noise, something has gone wrong and I need to correct. I need to continuously learn that there is something wrong in the system. Because of making privacy, I cannot compromise on my accuracy, what I'm predicting. And that's how it works in a typical system. Like I say, think of a hospital where you have patient disease information, age, sex, all those details. I don't want to disclose my health information or my disease information. Registers patients comes. There are undiagnosed patients also. So what happens first is the encrypted data, history of encrypted data flows to the training server, along with real-time information, the registered patient's direct data, encryption initiation. Then there's the training process, distributed training, because it's huge. You have to maybe use GPUs. Then you receive the encrypted train data, and that encrypted symptom data and public with the, when you are encrypting with the patient public key, you have the encrypted and it goes and flows into a chain, and you have the encrypted diagnostic data. See, the registered patient's data flows to the historic information. We get trained, outcome comes, the outcome is again encrypted, and with the public key, you send it back to the diagnostic results. It is no part of it, it is disclosed to outside world. Now, what are the challenges? Even if we do like a simple encryption based end-to-end, we are encrypting data at the source, we are encrypting data at the training, we are encrypting data while predicting, giving it back encrypted results. What could go wrong? The devices, if you put encryption key and all, it's going to be too heavy, because federated learning, many devices are participating. Model download, model upload with the key, and they may run out of battery, or they may run out of power. There's a lot of overhead. Multi-party secure communication. Different parties communicate, they agree who is going to communicate with whom, and all the parties exchange key information, and the data is also securely maintained. But is that enough? It's not enough. Where is the application level privacy going in? So what we do at Sapient, we have a lot of clients where we see different kinds of information coming in, healthcare, automobile, retail, where we do recommendations. So we have to handle a lot of sensitive information, and that's how what we try to do is boost the operational productivity of AI systems by producing, not only giving them real-time recommendations or real-time insights, enterprise insights, but infusing privacy at every layer of it. Optimize the value chain and enrich the privacy-driven recommended systems, or the predictive systems, with digital twins, so that when our predictions are real-time and we can have remedial actions immediately, if anything goes wrong even in a private system, we are able to handle. That is the risk mitigation and reduce risk and fraud. So that is how the end-to-end systems should work at. We should look at how do we build these end-to-end systems. Not only privacy, but also giving an accurate real-time results. And one of the application level privacy is differential privacy. When you train models, you ensure that even if a single data set is different, if you see these two figures, there's a boy and the woman in the left-hand side are different. The model outcome should not be such that we are able to make out that these two data sets are different in so many ways. That is to say, the probabilistic distribution or the probabilistic outcome of these two different data sets should be less than e to the power epsilon. That is, we call we're not going into too much technical terms. So the key thing is, we should not be able to distinguish the model outcomes of two data sets which differs by a single record. Even if I have two data sets and they're differing by a single record, the outcome should be such that we are not able to differentiate those. This is mathematically so much, it's e to the power epsilon and all, and then we add noise, and this is the sensitivity we call how much noise we are adding. So let's not go into too much detail, but if you are interested, we can talk about, I have the demo also. But it is like our outcome, we can measure when we are building models, when we are deploying, we can measure how is my sensitivity, how is my privacy budget, am I having too high budget? And if I have too high budget, it does not mean bad, because my data set may be too huge. So I need not bother, but I should have based on my data set, I should do a profiling. So what's the best privacy and accuracy trade-off I can have, and that the business allows me to do. And apart from that, we have already talked about like encryption key, that's at the communication level, at the transport level that is happening. So we can also introduce other measures like restrict the prediction vector to top K classes. We don't have too many huge classes. We have five classes selected. We increase the entropy as much as we increase randomization, our solution is more private. We round up the numbers that we are giving in the predicted outcome. Control overfitting. Overfitting is also one of the reasons that we leak, the models have leakage. And now comes when you're scaling the systems, you have to be very careful that you are adding the right amount of noise and maintaining privacy at the right level. Otherwise, what will happen in a location-based system, a small change in the noise, you're adding 0.01 randomized noise. And that to 0.01 goes, your latitude and longitude changes, and you're going by say a city which has a river or which has a lake. If you have added a bit wrong noise, you are ending up adding privacy, means you are going and falling into the lake. If you have added noise in such a way, the noise is not proper, we are not going by the road, we are falling into the river. So that things needs to be encountered. How is my accuracy also taken into consideration? When we are aggregating data from numerous sources, how is the confidence of the data inbuilt that our predicted outcome does not deviate the actual what is expected? Now, one is the predicted outcome, another is the when you scale database systems, aggregate queries, add noise. Again, you can add noise, just don't reply, right? Select this and this, just add some noise, random noise to this. Select count star plus 1 by epsilon, just some random noise add. And for larger systems, we don't account the privacy as the entire, we account the privacy of the entire system by taking subsystems into consideration. What is this system? If you see the partition, if you split into partitions and run query on each partitions, we see that how much is the privacy that is accounted by each systems. So here also, we don't select sum directly. We try to aggregate results, select sum, then max, then mean, and then it already gives the level of aggregation, hiding the actual information. If you select sum, you will get a number. How do we anonymize the data? That doesn't return the actual number. So this is all. You can go through the chorus. This is an open source tool which allows you to do. And if you think of implement it in a real-time embedded systems, you can have client, you can have edge networks, and you have server one side. Just keep it simple: client, edge, and server. And the client, you do all processing on the client side, feature extraction. On the edge side, 1 ML, 1 machine learning model, and from your different edge networks are connecting to the server. And the server builds, averages, aggregates different edge networks, and sends the global update to the client and pushes that to the edge. And this continues. Whenever we think of privacy, we have to think of, we have a pipeline in place that is continuously learning, predicting accurate results. If not, it is correcting. It is in a loop. Feature, we aggregate, extract the features, we add noise, push it to edge networks, from edge to server, continuously. And that's one more post-convergence, but what we say is, even after building our model, you can add some noise. This has high trust in the systems. That is the Bolton DP. Not going into so much details, it's too technical, but if you are interested, we can talk. But the one important thing we should remember, this Bolton DP it maintains different, when we put recommendation systems and all, it maintains the products, subproducts, even if you add noise, the relationships. That's why we would prefer to use Bolton DP. So all these models comes from different devices. It has convergence, then after convergence, we add noise. Simple thing. And then it's easy integration. It has different models combining, more privacy, better utility, less runtime overhead. And it allows building models with siloed data. So some of the code samples and all, if you use a simple regularization and simple optimizer in Bolton DP, you will use a convex optimizer. And for normal differential privacy, you will use a DP Adam optimizer or DP Adagrat optimizer. These are the changes. If you go into TensorFlow library, you will learn. Instead of normal Adam optimizer, you will use a differential private optimizer. That's how. And that is the most important thing. How do we accept them, maintain the trade-off? And we can do it at local level or global level. Local level means here you see the global differential privacy. Another trusted curator adds the noise for individual participants, but for local, the individual devices are adding their noise before the model is generated. So these are some of the areas that we should look at while scaling. And why Bolton DP? The most important thing is it's scalable. It has a research background behind it. So if you may want to try it out, how it works. Yeah. And one is that with the TensorFlow privacy, we have seen some results, like if we get data from different sources, IoT and all devices, or we do text classification, also we need to add privacy. We can add noise. And that optimizer will take into consideration, even if you have added noise, what is your degree of convergence. We do micro batches. Even if you have expert in deep learning, you will know that for mini batches, we are going into the concept of micro batches to allow each point how much noise I'm going to add, and also how much gradient I'm going to clip, means how much noise I'm going to add and how much gradient I'm going to apply to that, so that the gradients which are learned into the final outcome are not expecting that, are not allowing that point to be discovered by that attacker. The entire aim is not to let the point getting discovered, actual record getting discovered by the attacker. So that's how it works. There are numerous parameters you can configure, like one is the clip, and one is the noise multiplier, one is the, you can estimate the sensitivity, then one is the privacy budget. It will let you know that your solution is private and not. Now, I would just request you at the last, like, how do you apply privacy in Apple, and what is the challenge you are facing? So are you facing challenge if you have used in your organization into apply privacy, or where to apply privacy, or scaling it? What is the main challenge that you're facing? Anybody? Anybody has tried to use privacy in their organizations? Nobody, even in businesses, if you're thinking of that, you have to answer to your stakeholders. So anybody has raised question that, yeah, my data is private. How do you go by GDPR? How your framework is private? Anybody, any questions? I'm trying to look at questions. No questions. Nobody has.
I'm also noticing, trying to watch. Nothing there, nothing in the chat as well.
Okay. Okay. So if you have any questions, you can get in touch with me in LinkedIn. But the main takeaways are
there's something that came in which said, how do you prove trust and provenance? I don't know whether it came before you.
Yeah. Yeah, how do you prove trust and provenance? A very good question. There is no way you can prove that this system is trust and provenance unless and until you had an attack, you had a real-time attack, and you have been able to show that you have been able to protect sensitive information of your customers. What are your audits? Has there been any DDoS attack, even DDoS attacks? Have there been any attacks from external systems, or have there been any attackers? Your logs will say that the repeated IPs coming into picture. It is not, doesn't look like a normal person who is trying to access your model. So to react to that, what are the counter features that you can prove that because you have seen at this time this has occurred, and you reflect back to your systems, like what model outcomes you had, and at that time around what has been your accuracy and what has been your privacy budget. And if there been a DDoS attack, have been reactive to that? Have you been able to scale and manage that? Have you been able to block those IPs? So it is not just a model, but it has to be a full end-to-end pipeline, big data, data ingestion, data governance, data audits. You are auditing your systems, and that audits will give you that how much resilient you are to such external threats. Only the audit reports will prove that how much trust customers can have on your systems. But that is more reactive. How to be proactive and demonstrate trust. So proactive measures are like having privacy end to end. So that we have talked about. So not only machine learning, your data ingestion, encrypted data, storing data at each storage space, your database, your cache, your if you're storing in other databases for continuous processing, your feature stores, think of your feature stores. Every place it has to be anonymized. Your keys should be rotating. Every place your keys should be rotating. Even models should be rotating. Then you have could also have implicitly private networks through privacy keys similar to encryption, internet encryptions. So is there somebody answering, I think, or this is not a question? So yeah.